astronomers have mapped out several rare and measurable sky events that will happen within this century, including a close asteroid flyby, the return of Halley's Comet, and a possible stellar explosion visible from Earth. These are not predictions based on speculation, but on decades of observation and precise orbital and stellar data. Together, they form a timeline of real astronomical milestones that many people alive today may actually witness. In this video, we will walk through what these events are, when they will happen, and why they matter. Let's get started. Modern astronomy no longer depends on waiting for the sky to surprise us. By combining telescope observations, spacecraft tracking, and gravitational modeling, scientists can now forecast many of the most important celestial events decades into the future. Several of those events will unfold within this century, and they are among the most precisely predicted phenomena in space science. One of the most widely discussed is the close approach of asteroid 99,942 Apophis in April 2029. Apophis is a near-Earth asteroid about 370 meters wide that was discovered in 2004. Early measurements briefly suggested a small chance of impact, but follow-up tracking refined its orbit and ruled out any collision for at least the next 100 years. What makes the 2029 event remarkable is how close the asteroid will pass, about 32,000 kilometers above Earth's surface, inside the orbit of many satellites. For observers on the ground, Apophis will appear as a fast-moving point of light crossing the sky, visible without a telescope across much of the planet. Another event that has been calculated with similar confidence is the return of Halley's Comet in 2061. Halley is a short-period comet that orbits the Sun every 75 to 76 years and has been recorded by astronomers for more than 2,000 years. Its last appearance in 1986 was poorly positioned for observers on Earth, making it relatively faint. In 2061, the geometry will be far more favorable, allowing the comet to come closer to both the Sun and Earth, which should make it significantly brighter and easier to see. Beyond our solar system, astronomers have also identified a star system that is approaching a dramatic turning point. V Sagitti, located in the small constellation Sagitta, is a close binary system whose brightness has been steadily increasing for more than a century. Measurements of its orbital period show that the two stars are spiraling toward each other. Models predict that this process will lead to a major outburst sometime late in the century, most likely around the 2080s, although the exact year remains uncertain. Planetary motion also provides one of the century's most visually striking events. Jupiter and Saturn align in the sky roughly every 20 years, but in March 2080, the two planets will appear especially close together and far from the Sun's glare. This will make the conjunction visible around the world under good viewing conditions, creating one of the best opportunities in generations to see both planets in the same patch of sky. These events are not guesses. They are the result of long-term observation and careful calculation, forming a reliable map of what the sky will look like in the decades ahead. While these events will be visually impressive, their deeper value lies in what they allow scientists to test and measure. Apophis, for example, will provide a rare opportunity to observe how a real asteroid responds to a close gravitational encounter with Earth. As it passes our planet in 2029, Earth's gravity will subtly stretch and reshape the asteroid. This may alter its rotation, disturb loose material on its surface, and slightly modify its orbit. By tracking these changes with radar and telescopes, scientists can directly study how near-Earth objects behave under strong gravitational forces. That information is essential for understanding how asteroids evolve and how they might respond if one ever needs to be diverted from a dangerous trajectory. Halley's Comet serves as a natural laboratory for comet physics. Because it has been observed for so many centuries, astronomers can compare its behavior from one return to the next. When it comes back in 2061, researchers will measure how much gas and dust it releases, how its tail forms, and how its nucleus has changed since the last visit. These observations help answer fundamental questions about how comets age, how they lose material, and how long they can survive repeated trips around the Sun. V Sagittae offers insight into some of the most extreme processes in stellar evolution. One leading theory suggests that the system contains a white dwarf pulling material from a larger companion star. As this material builds up, it can eventually trigger a powerful nuclear eruption. Another model proposes that the system involves a Wolf-Rayet star, a massive and unstable type of star that sheds its outer layers at high speed. Both scenarios point toward an energetic outburst when the two stars finally interact more directly. Observing that event will allow astronomers to test these competing ideas and better understand how certain kinds of stellar explosions occur. Even the Great Conjunction of Jupiter and Saturn has scientific significance. The precise timing and motion of these planets over long periods allow astronomers to test the accuracy of gravitational models. When the two planets align so closely in 2080, their positions will be compared with predictions made decades earlier, providing a real-world validation of our understanding of planetary motion. Together, these events touch on nearly every major area of astrophysics, from the behavior of small bodies to the life cycles of stars. These upcoming events will shape how astronomy is practiced and how the public engages with space science. The 2029 Apophis flyby is already driving new research and mission planning. Radar systems will map the asteroid in detail as it passes, while telescopes will track any changes in brightness or rotation. Some proposals even involve sending a spacecraft to observe the encounter from close range. The data collected will improve models of asteroid structure and motion, which are central to future planetary defense strategies. Halley's return in 2061 will provide a rare chance to observe a famous comet with modern technology. High-resolution instruments will be able to analyze its chemical composition and the fine structure of its coma and tail. These measurements will give scientists new clues about the materials that form the early solar system and how those materials have changed over billions of years. If V Sagittae undergoes its predicted outburst, it will become one of the most studied stellar events in history. Telescopes across the electromagnetic spectrum will track its rise and decline, measuring everything from visible light to X-rays and radio waves. The results will help clarify how different kinds of binary star systems evolve and how some of the universe's most powerful explosions are triggered. The Great Conjunction of 2080 will serve both as a public spectacle and as a technical benchmark. It will offer an unusually clear view of Jupiter and Saturn together in the sky, while also confirming how accurately astronomers can predict planetary motion far into the future. Beyond these scheduled events, the sky will continue to produce surprises. New comets will arrive from the outer reaches of the solar system. Meteor storms may occur when Earth crosses dense streams of debris. At some point, a star in our galaxy will go supernova, briefly becoming one of the brightest objects in the night sky. These cannot be forecast in advance, but history suggests they are inevitable. Together, the known and unknown events of this century show that the universe remains active and dynamic on timescales that overlap with human lives. The century ahead is filled with real, measurable cosmic events that humanity will witness in real time. Each one offers a rare chance to test our understanding of how the universe works. The sky is not just changing, it is revealing its future.